Hello all, in this video, we will learn about unit portion in physics. Use the next session to explain units, the backbone of physics. Introduction. A big part among the many advice of physics that bridges measurement and understanding is unit that serves as a fundamental concept. Whether we are addressing distance, times, mass, or the units for any other physical quantity, the units will help us to count and compare different phenomena through the quantities. A form of 8th grade physics, which involves units in defining the laws that we observe in nature, is paramount at comprehending the importance of these units as they contribute to our understanding of nature. What are units? Units are standard quantities agreed and uniformly applied to express and compare measurements of physical quantities. They act as the benchmark relative to which measurement of any phenomenon can be interpreted in any language. Leave units off and it is hard to communicate about the very specific type of quantifiers including length, time, temperature, and so on. Types of units. In physics, there are two main types of units, fundamental units, the base units, and derived units. The difference is that base units are not defined in terms of other units, and they are meaningful to all of us. Both base units include the meter, m, for length, the second, s, for time, and the kilogram, kg, for mass as examples. And for the same quantities are derived units, not simple base units but combinations of them. As a sample, the unit for speed is meters per second, ms, which have been obtained by multiple metrical units of length and time or its mathematical combination. Along with the reproducible units, there are derived units such as the Newton, N, for force, the joule, J, for energy, and the watt, W, for power. The importance of units. Units serve several critical purposes in physics. Units serve several critical purposes in physics. Standardization. The units give scholars a regularized design basis for evaluation. This allows scientists worldwide to interact without difficulties. Precision. Through units, measurements can be conveyed in a precise and accurate manner based on the consistency in measurements to assist users in the handling of the measurements. Such a statement as 5 meters long expresses more precise information rather an ordinary 5. 3. Consistency. The units give the uniformity in different disciplines of study and experiments. Although when measuring the speed of a car or the energy produced by a nuclear reaction we should use the same units in order to make the comparison meaningful. Conversion. The units let us convert from one system of measurement to another. For instance, we can convert between meters and feet or between Celsius and Fahrenheit. Examples of units. Undefined. Meter, m. The meter is the basic unit of length in International System of Units, c. It is a physical unit that represents the distance light travels in vacuum in 1/299, 792, 458 of a second. The meter is employed to determine lengths, ranging from the micro scale of the atom to the colossal scale of intergalactic space. Second, s. The second is the base unit of time in the C system. This is regarded as the period for 9/190 to 631 770 cycles of the radiation linked to the transition between two hyperfine levels of the ground state of the cesium, 133 atom. Time measurement is implied in many activities, such as the daily activities and celestial phenomena. Kilogram, kg. The kilogram is a base unit of mass in the C system. The current definition of the kilogram is linked to the mass of the international prototype of the kilogram, which is a platinum iridium alloy cylinder stored in the International Bureau of Weights and Measures in France. Mass measurements play an important role in such fields as engineering, chemistry, and astronomy. Newton. The Newton is the unit of force derived in the C system and is named after Sir Isaac Newton. The unit of force, 1 Newton, represents the force necessary to accelerate 1 kilogram mass to 1 meter per second squared. The forces are primary in the mechanism of the interaction of the objects in the universe. Joule. Joule is derived unit of energy in C system. It refers to the work done when a force of 1 Newton is applied over a displacement of 1 meter. Energy measurement plays important role in explaining different physical phenomena including mechanical work, heat, or electromagnetic radiation. Watt. The watt is the derived power unit in the C system, which is named for James Watt, a Scottish engineer. 1 watt is the energy produced by an energy transfer of 1 joule per second. Power levels are critical in engineering, electronics, and the field of energy generation and utilization. Conclusion. Conclusively, the notion of units is the bedrock of physics. Through uniform indicators, scientists are able to communicate well, make accurate measurements and compare various phenomena. Being an 8th grader who is on a quest to explore physics, understanding units is what paves the way for a deeper understanding of the universe and its basic laws. Therefore, take on the world of units, and let your wonder guide you to the capturing universe of physics.